Hello, my dear students and the rest of the learners. Welcome to part 10 of a 7-part series of tutorials in the topic or in the unit, Computer Structured Programming Unit in C and Pascal. This is section 4 of 5 in the topic, Program Structure. My name is Mehmet M, or you can simply call me Emily Swap. In this tutorial, or in this presentation, I'm going to discuss identifiers, where I'll talk about standard identifiers, the user-defined identifiers, the constants, variables, and then I'll look at expressions. Let's begin by looking at identifiers. These are the names given to any object or elements in a program, such as constants, variables, or code segments. They are used to identify the memory locations set aside to store values. The 4 main rules for identifiers are: number 1, they must start with a letter of the alphabet. Number 2, they must never start with a number. Number 3, they should not have special characters. Number 4, they should not have spaces between them. And therefore, an identifier can be made up of a single letter or could be made using several letters and digits. The 2 types of identifiers in programming are the standard identifiers and the user-defined identifiers. What are they? The standard identifiers are those names that have a predefined or special meaning in a programming language, but they can be redefined by the programmer to serve different purposes. However, they should be used according to their predefined functions as far as possible. Examples in Pascal include Boolean, the char, end of file, end of line, integer, read, read line, write, cos, xp, round, square, square root, absolute, or ABS. In other ones, we just write them as Boolean, char, EOF, EOLN, integer, read, read line, write, cos, EXP, round, SQR, SQRT, ABS. But in full, they stand for Boolean, character, end of file, end of line, integer, read, read line, write, cosine, exponent, round, square, square root, absolute. Examples in C include scanf, printf, amongst others. The difference between standard identifiers and reserved ones is that reserved ones are those ones that have a predefined meaning that cannot be redefined by the programmer. They are also called key ones. Examples of reserved ones in Pascal include begin, end, program, var, const, label, procedure, function, array, case, do, then, record, else, while, with, div, type. Examples of reserved ones in C include void, return. Let's use a look at user-defined identifiers. These are names that have no predefined meaning in a programming language and are used in a program by the programmer to identify the memory locations set aside to store values, that is data and the program results and to name operations that he or she defines. To make these identifiers be more readable, the programmer can make use of underscore. For example, student underscore name, or use both uppercase and lowercase letters suitably. For example, student name, student name. What are constants? These are identifiers for memory cells or locations whose value is not allowed to change throughout the course of running a program. A constant must be defined before it is used in a statement. The type of a constant is inferred from the data value specified. So, constants can be of different types based on the type of value they hold. For example, numeric, string, etc. The definition of a constant is achieved by using the reserved word const. In Pascal, constants are defined in the following syntax. Const name equals to value semicolon. For example, const pi equals to 3.142 semicolon. How do we read this statement? In programming language like in Pascal, it simply means assign the memory location assigned called pi. I repeat, assign 3.142 to the memory location called pi, whose value will not change during program execution. So const pi equals 3.142 semicolon performs two things. Number one, it declares a memory location called pi. It declares a memory location called pi. Secondly, it assigns that memory location a value. So this statement, const pi, this statement is both a declaration statement and an assignment statement. Const pi equals 3.142 semicolon. It means we are declaring a memory location called pi. We are requesting the compiler to set a memory location assigned called pi that will hold a value which will not be changing. And what value? So next step, we assign that memory location called pi a value, which is 3.142. So in other words, this statement reads as follows. Set a memory location assigned called pi, whose content will not be changing, and assign to it or store in it 3.142. Store in it 3.142. So set a memory location assigned called pi, whose value will not be changing. And then store in that memory location, figure 3.142. While in C, constants can be defined using any of the following syntax. Const data type name equals to value, semicolon. For example, const double pi equals to 3.142, semicolon. How do we read this statement? It means set a memory location assigned to accommodate a number which has a decimal point, and that number, that figure will not be changing. Then store in it value 3.142. So it is it's a declaration statement and an assignment statement at the same time. It is declaring a memory location called the pi, which will contain a number with a decimal point. But that number will remain constant throughout the processing period. And then next is store 3.142. We can also do it with hash define name value semicolon. For example, hash define pi 3.142 semicolon. So those two statements, constant double pi equals 3.142 semicolon, and hash define pi 3.142 colon or semicolon, they both mean the same. Let's look at the variables. These are identifiers for memory cells whose value is allowed to change during the course of execution of a program. They must be defined before they are used in a program. So they are names that are given to represent a piece of data that can be changed or varied while the program is running. A variable definition establishes that the identifier is a variable and specifies the type of value it can hold. So, depending on the type of value a variable is to hold, variables can be of different types, such as numeric, string, character, amongst others. Initialization is the process of giving a variable some initial value during declaration. The following are some examples of initialization in C. Int mark equals 20. This statement means, or this statement is a declaration statement, which is also initializing a value. So it is setting a memory location assigned called mark that will hold a number without a decimal point. And then it is storing into 8 value 20. So this is called initialization. And for that reason, we can also say that this statement that is declaring the constant pi equals to 3.142 semicolon, we can also say that const pi equals 3.142 semicolon can be read as set a memory location assigned that will not, or that will hold a value which will not be changing, and call it the pi. So set a memory location assigned called the pi that will contain a value which will not be changing. Then the next action is we are initializing, we are storing in 8 a value 3.142. And therefore, we can also say, or we can still say, that this statement performs 2 tasks. It creates a memory location of type const, and it initializes into 8. In other words, it assigns into 8 a value during declaration. It assigns into 8 a value during declaration. So anytime you have declaration statement that is also, or that is declaring a variable or a constant or a memory location, and then a certain value is being stored in that memory location, we call that initialization. You are storing into 8 the very first value. So you create and store something into it. You initialize that memory location with a certain value. So it is an initialization statement and declaration statement at the same time. So int mark equals to 20. So we are setting a memory location aside called mark to hold the value that is a whole number, and a value is being assigned into 8. In other words, it is being initialized with value 20. Set a memory location assigned called A, which will hold data of type character. And we are initializing that memory with character A. Set a memory location assigned called name that will hold a series of characters or a string whose size should not exceed 10. And then initialize it. Store the first value into 8, which is meme, semicolon. These variables can be initialized as follows in Pascal once they have been declared in the declaration section. So this is how we do it. After you have declared int mark char A or char or string name, then mark 20. In other words, you can assign 20 to the variable called mark. So these statements here, assign 20 to mark, assign character A to memory location called A, assign meme to memory location called name. These ones are simply ways of initializing memory locations after you have already declared in Pascal. What about expressions? What are expressions? An expression is a statement composed of operators and operands that returns a value. They are made up of operands which are connected by operators, and it denotes a value. The two main types of expressions are numerical expressions and Boolean expressions. Numerical expressions have numerical values, and Boolean expressions have a truth value, either a true or false. In numerical expressions, the operands must be of integer or real types, and they use the arithmetic operators. Boolean expressions are used in control structures, and they make use of the relational and logical operators. Some aspects of valid expressions are, number one, two operands or operators cannot appear consecutively. Number two, a single variable or a constant is a valid expression. Number three, a function name is a valid expression and can also be used within expressions. Arithmetic expressions are statements that deal with the performance of computational tasks or data. They involve assignment statements, arithmetic operators, relational operators, the logical operators, the standard number, and the character functions. The assignment expressions assign the result of an expression or data items on the right to whatever variable is on the left with the use of an assignment operator. An expression must be of the same data type as the variable to which it is being assigned. Calculation statements are always written with a variable being assigned the value of a calculation rather than a calculation being assigned a variable. A condition is an expression which, when evaluated, gives either a true or a false value. This expression is called a Boolean expression. Those conditions use the relation operators between two variables or between a variable and a constant. Expressions with multiple operators are executed based on the order of precedence of the operators involved, and the results of an expression can either be stored in another variable or output. For example, pick the content of memory location code A and to the content of memory location code C, and the results, assign them or store them in memory location code A. Or write B plus C in Pascal. So you can also have a statement like this in C. A equals to B plus C. Then primitive identifier for integer %d, comma, B plus C. In other words, this statement primitive means or reads as follows. Output the content of, or output the sum of the content of memory location B and that of memory location C as an integer on the screen. The following are the main rules for evaluating expressions. One is parenthesis rule. It says that all expressions in the parentheses must be evaluated separately. Nested parenthesized expressions must be evaluated from the inside out, with the innermost expression being evaluated first. The second rule is called operator precedence rule. It states that operators in the same expression should be evaluated according to their order of precedence. The third rule is called associativity rule. It states that unary operators in the same sub-expression and at the same precedence level, such as addition and subtraction, are evaluated from right to left. We call that right associativity. Binary operators in the same sub-expression and at the same precedence level, such as addition and subtraction, are evaluated left to right. We call that left associativity. For example, if you have the following equations that you would like to implement using a program, like A equals to pi r squared, then if you have another one called or expression like 3a squared plus b squared equals to c, and another one like x equals to 1 over 1 plus x, and another one like m equals to bracket x plus y minus 3 bracket over c minus d, then you can implement them as follows in Pascal and in C. For A equals to pi r squared, you write it in Pascal as pi times r, assign that result to memory location called A. But in C, the assignment operator has no colon. So it is A equals to pi times r, semicolon. In other words, we did it as pick the content of memory location called radius, multiply to the same value, radius, then multiply by the content of memory location called pi. The results you are going to get, store them in the memory location called A. Assign them in memory location called A. What about this other expression? 3a squared plus b squared plus a equals to c. We write it in Pascal as follows. C, in other words, we read it as follows. Pick the content memory location called B, multiply by itself. the results that you are going to get, add them to the results you are going to get from or by picking the content of memory location recorded A and multiplying by itself, and then multiplying that result by 3. So whatever you are going to get after multiplying or squaring A and then multiplying it by 3, whatever value you are going to get, add to the value that you got when you squared B, or the content of memory location recorded B. The answer or the final results, store them or assign them to the memory location called C. My dear students and the rest of the learners, kindly note the way I am explaining. Like in this expression, I'm saying, pick the content of memory location called B, multiplying by itself. Whatever answer you are going to get, you will add 8 to the answer you are going to get after multiplying the content of memory location recorded A by itself and multiplying it by 3. Whatever you get, you add the 2. The answer you are going to get, the final answer, stored it in the memory location recorded C. So that is in Pascal. And it is the same in C. The only difference is the assignment symbol or operator. For x equals to 1 over 1 plus x, in Pascal, you write it as follows. The operator, the assignment operator is as follows in Pascal. So, how do you read it? Or how is it worked out? It is simply means get 1 divided by 1 divided by the results of the memory location recorded x, the value of memory location recorded x, and then to 1. In other words, let me put it in a clearer way. This expression means pick the content of memory location recorded x, add that content to 1. Whatever answer you are going to get, divide 1 with it. Divide 1 with the answer you are going to get. So that is 1 divided by the total you are going to get after adding the content of memory location recorded x with 1. And the same applies to C. The only difference is the assignment operator. For m equals to bracket x plus y minus b, close bracket divided by c minus d, you write it as follows in Pascal and also in C. It simply means get the content of memory location recorded C, subtract the content of memory location recorded D from it. In other words, subtract the content of memory location recorded D from the content of memory location recorded C. Whatever answer you are going to get, have the content of memory location recorded x and then y minus 3 divided by 8. In other words, you can simply say this way. Get the content of memory location called x and the content of memory location called y. Whatever you are going to get, subtract 3 from it. The final answer you are going to get divided by the answer you are going to get after subtracting the content of memory location called D from the content of memory location called C. The final answer you are going to get, assign it or store it in the memory location called M. The same applies to C. The only difference is the assignment of. And with that, we have come to the end of this section 4 Continue to section 5 or 5 in this topic in the next part in this series. Congratulations for learning section 4 or 5 of the topic program structure. You can also access section 1 to 5 of this topic, other topics in the computer structure programming unit, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. You can also visit MLSWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to this channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in the next part in this series, and God bless.